there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about the equation of a circle. So let's talk about things we should already know from Hegarty Maths. Previously, in the geometry section, we've talked about what a circle is, and I'll explain that briefly again. Now imagine, to make a circle, imagine I was in the playground, there's Mr. H, and I had a class of pupils with me, and I said to one of them, stand 5 meters away from me, and they stood there. And I said to another, stand 5 meters away from me, but you can't stand on top of the other person. And they stood there. And I kept asking my students to stand 5 meters away from me in a new unique spot. And can you imagine that they start standing 5 meters away from me in all sorts of directions as follows? And we end up forming a circle. And this is what a circle is really all about. A circle is the set of points that lie a fixed distance, which we call the radius, from a center point. So before, that was me in the middle of the playground, there was the center, and a circle is the red line drawn out by all the points that are a fixed distance, which is the radius away from the center. Okay, and that's the definition of a circle, and it's going to be really useful for us when we're doing some coordinate geometry and the equation of a circle. Right, you need that. Next thing you need is to remember the distance formula. The distance formula between 2 points in the Cartesian axes or in the plane. Pause the video and double check you can remember how to work out the distance between a general point x1, y1 and x2, y2. And the formula for this distance is given by lowercase d is equal to the square root of x2 subtract x1 all squared, add y2 subtract y1 all squared. And just to give you a flavour of why that was true, it was an application of Pythagoras' theorem. If you remember, if you're trying to work out this distance there, which you may draw in and you may label lowercase d, in order to find that distance, you could find it by creating a right angle triangle like this, and applying what's called Pythagoras' theorem to that right angle triangle, and finding this side and this side, squaring this side, adding it to the square of this side, and you would get the hypotenuse squared. Now, how would you find the length of this side? Well, let's just fill in what this coordinate must be. This coordinate is the same amount across as this point, so it must be x2 across. And it is the same height or y value as this one here, so that must be its coordinates. And therefore, if you are applying Pythagoras' theorem, you need this length and this length, the shorter length. So this length here is going to equal, well, it's going to equal the difference in the x coordinates, x2 subtract x1. And this length here, okay, the height is going to be the difference in the y coordinates, which will be y2 subtract y1. So therefore, you would state therefore that by Pythagoras, the hypotenuse squared, which is the distance squared, is going to equal x2 subtract x1 squared, the base, add y2 subtract y1 squared, which will be this perpendicular height here. And taking square roots of both sides, you would get the formula for the distance. And that's going to be really important when we're defining circles. So just to practice using this formula, imagine I asked you the following question. What is the distance between the coordinate -6, -7 and +3, +5? Apply this formula here and work it out for me. Well, you should have got the following. Okay, you should have got that the distance would have been 15 if you had just applied this formula here, and on x2, 3, subtract x1, which is subtract -6 all squared, add 5 subtract -7 all squared, and taking square roots, you would have got 15. So we're going to need to use that formula and be good at the distance formula. Right, it's time to actually start talking about where the equation of a circle comes from. Suppose we had the following circle. We could say, because this is a right angle triangle, 5 squared must be equal to this distance squared, and this distance is going to be how far across you've gone, which is 7 take away 3, so that's going to be 7 subtract 3 all squared, and this height, which is going to be 4 subtract 1, so that's going to be 4 subtract 1. And we could check if that holds. Well, 5 squared is 25, and 7 take away 3 all squared is 4 squared, and 4 take away 1 all squared is 3 squared. And again, it's true that 4 squared is 16, 3 squared is 9, 16 add 9 is equal to 25. That holds. And in general, rather than say this is the point 74, we could have called this the point xy, any point on that circle. And we could have said it holds the equation 5 squared should be equal to, and it would look exactly like it does above, identical to above, in fact, okay, other than it would be x subtract 3 all squared, and it would be y subtract 1 all squared, because xy is a general point, not 7, 4. And suppose we went even more general, we said that the center point wasn't 3, 1, it was some general numbers a and b, and we said the radius wasn't 5, the radius is some unknown number r. We could state that the equation of a circle would be r squared by Pythagoras is going to be equal to, it's the identical format to what we've currently got. Apart from it would be x subtract what's in place of 3, a, and it would be y subtract what's in place of 1, will b. And this is known as the equation of a circle, and we have generated the equation of a circle there. R squared is equal to x subtract a all squared add y subtract b all squared, where r stands for the radius and a and b are a fixed center point, and x and y are just any points around that circle. So let me represent this a little neater for you. Here's a picture showing the equation of a circle. For any point xy on the circle, we know the following formula holds: x subtract a all squared plus y subtract b all squared is equal to r squared, where ab is the center and r is the fixed radius. And x and y can move around the circle. You can see here x and y can be anywhere in the circle, but the radius is always fixed and the center is always fixed, and that formula will always apply. So what you need to be able to be good at is, if you see an equation in that form, you need to be able to state the center. If it's in the form x subtract a all squared plus y subtract b all squared is equal to r squared, the center is positive a and positive b, and the radius is r. Also, you're going to need to be able to when you're given the center and the radius, write it in the equation of a circle form. So let's have a go at some questions. Pause the video, have a go if you think you can do. Okay, this is in the form we want. X subtract a all squared add y subtract b all squared is equal to r squared. Perfectly in that form for us, where the center is 1, 3, okay, and the radius, that's the center, and the radius is going to be what you square, which is 4. So 4 is the radius. So we could draw a little sketch of that. We can just think of ourselves as going across 1 and up 3, something like that, and the radius of 4, let's draw a circle, and the radius of 4 means it's going to go slightly lower than this height of 3 here. So if we draw a radius of 4, it's going to be a bit like that there, and this here was the center 1, 3, and the radius, which we'll draw maybe down like that, is going to be something like 4, and we're done. Alright, there's a sketch. Let's try another one. Pause the video, have a go. Well, that is in the form we want, but let me just show it to you more clearly. Here's the form we want: x subtract a all squared add y subtract b all squared is equal to r squared. That's the way we want it. So we've nearly got that, other than it's x subtract 5 all squared, the subtract's right, but we have to think of y add 3 as y subtract negative 3. So it's in the right form, because subtracting a negative is the same as adding. It's 2 squared. And that therefore tells you that the center of this circle is at 5, but not 3, negative 3, and the radius of this circle is the number you square on the right hand side, which is equal to 2. So we can draw that there. We can say 5 across and 3 down, somewhere like there, 5 across and 3 down, and the radius of 2 means that circle won't cross this x-axis here, so it'll be something like that, and we can draw in the fact that we've got a radius of 2, like that, and we're done. Let's have a go at another one. Pause the video, have a go. Again, we want it in the form x subtract a all squared add y subtract b all squared is something squared, r squared. Okay, now it's nearly in that form, isn't it? But we need to here do our little trick and say that adding 1 is like subtracting negative 1 all squared, add y subtract 2 all squared. Now 16 is not our radius. You have to think what squares to 16, write it in the form 4 squared. Therefore we know our center. Our center is going to be negative 1 and positive 2. And our radius is going to be the number that we square, which is going to be 4. Let's draw this circle, back 1 up 2, center somewhere here, and a radius of 4. And that's it, we're done. Last one, pause the video, have a go. Now you might think to yourself, how is that in the form x subtract a all squared add y subtract b all squared is equal to r squared? Well, it kind of is. If you think about it, you're subtracting nothing. So this is x subtract 0 all squared, add y subtract 0 all squared is what squares to 25? 5 squares to 25. So in this particular case, the centre is the coordinate 0, 0, isn't it? And the radius here is equal to 5. So we can mark in our centre here at 0, 0, and we can draw a circle with radius 5. And in general, it's worth pointing out, if you ever see anything of the form x squared add y squared is equal to r squared, it has centre 0, 0. So it's something you start spotting when you see that very often. Centre 0, 0 and radius r. And that's it for this particular video. Thanks loads for watching.